The diagram shows a vertical radio mast AB. Three of the wires that hold the mast in place are attached to it at F, H, and D. The base A of the mast and the ends E, G, and C of the wires are in a straight line on horizontal ground. The wire CD has length 65 meter. Okay, so which length is it that we are referring to? This is the length that we are referring to. This length is 65 meters. So let's mention this. This is 65 meter. It is attached to the mast at D, where AD is equal to 40 meters. So this length AD is 40 meter. This length is 40 meter. Calculate AC. We have to calculate this length. There's no need to draw the triangle separately, only highlight the values which are given to you. So you can very clearly see that I have highlighted the triangle which I need to do business with is the one which is done highlight with the red line. Okay. So we have to calculate the length of AC. And in the triangle, I can clearly see that we know the hypotenuse and we know the perpendicular. We have to calculate the length of the base. The first part is going to be very straightforward. With the help of the Pythagoras theorem, I can say hypotenuse square is equals to, let's say, perpendicular square plus base square, which is AC. Okay, 65 square is 4,225, 40 square is 1,600 plus AC square. I'll remove this 1,600 and I bring it on this side. What is 1,600 doing on the right hand side? That is adding. When I move it to the other side, it starts subtracting. So I can write that 4,225 minus 1,600 is equal to AC square. And when I subtract 1,600 from 4,225, I get 2,625. So we can say that AC square is equal to 2,625. This is AC square. We'll take square root on both the sides to get the value of AC. I can cancel this square with the square root. AC is equals to square root of 2,625, which is 51.23. So the length of AC is 51.23 meter. Okay. Then we move on to part B. In part B, what are they saying? Let's not erase the values, only erase those lines. Okay. In part B, the wire EF makes an angle of 25 degree with the horizontal. Where is EF? This is EF. Here is EF. EF makes an angle of 25 degrees with the horizontal. So this is 25 degree, and this is the horizontal which is going on. I'll stop here. And is of length 30 meter, and the length of EF is also given. The length is 30 meter. Calculate AF. This is what I need to find out. Okay, so when it comes to solving part B, I can say that I know an angle, I know the hypotenuse, and I have to find out the opposite. So the trigonometric ratio which I need to use is sine 25 degree is equals to opposite is AF upon hypotenuse is 30. Sine 25 is equal to 0.422. I'll write 0.422 and I move this 30 over here. This 30 will multiply with the value of sine 25, which is 0.422. So I can multiply this value with 30 and I get 12.67. So AF is equal to 12.67 meter. Part C. In part C, they are saying the wire HG makes an angle of 30 degree with the mast AB. Okay, the wire HG, this is the wire HG and the mast AB. Okay, the mast is this. Okay, the angle that HG is making with the mast is this one. This is the angle, and this angle is how much? This angle is 30 degrees. Calculate HG. We have to calculate the length of HG, and we are given that AH means distance from point A to point H is 35 meters. So I can write that this entire length is 35 meter, the distance from A to H. Now that I know that 30 degrees is given, 35 meter becomes adjacent to 30 degrees. And I have to find out the length of the wire, which is HG. I have to find out adjacent. I have an angle and I have to find out hypotenuse in part C. So the trigonometric ratio which connects adjacent and hypotenuse is cos. So I'll say cos 30 degrees is equal to adjacent, which is 35, upon hypotenuse, which is HG. What I'll do, I'll switch them with each other, and we can say that HG is equals to 35 divided by cos 30. Let's find out the value of cos 30 and then write it over here, which is 0.866. This is 0.866. So HG is equals to 35 divided by 0.866. It is going to be 40.41 meter. That's your question.